to say something real quick, guys. We got another short week. So for those of you guys who don't know, we are taking another little quiz on Thursday. And all it is it's going to be over adding and subtracting. And I might put a few multiplying and dividing just as a little review. But again, this is honestly the last big thing that we're doing before I start reviewing with you and before I start working with you on your ERBs for the next couple of weeks after that. Now, again, listen, it is important, all right? This is really helpful for those of you guys who struggle with fractions still, all right? It will help you understand your adding and subtracting fractions right now. Again, we're just using, in the past, we've used just numbers, and now we're going to introduce you to the variables. All right, today's lesson, honestly, is kind of easy, all right, because for the most part, they will already have a common denominator. So, for example, if I said, what's 1/5 plus 1/5, you would tell me it's what? 2/5. Simply because they have the same denominator. Then, of course, you have to work at reducing the fractions. All right, I was also fussing at Connor a little bit, and part of it is, and I've told him, I'm trying to prepare you for high school just a little bit now. All right, and again, you have to do your work. All right, I'm telling you that some of the questions on the quiz, the last quiz, were the same questions that were on the review. All right, I'm really and truly not trying to make it hard. I'm trying to make it easy. And I'm trying to show you if you do your part, my part is easy. All right, and it's easy for you. All right, we only have a little bit more time together, and I'm trying to get you leaving here feeling like you're great at math, because most of you really are. We're just doing hard stuff. All right, and so next year you will be prepared. All right, but you have to do your part. And this section is particularly important because we're going to review everything you need to know about fractions to be successful. All right, and again, today's the first part of the lesson is very easy. Tomorrow you'll be adding 1/2 and 1/3. And what makes that more difficult? You have to get a what? You have to get a common denominator. All right. Well, if you don't know how to find a common denominator, then you're not going to know how to find a common denominator on these types of fractions. All right. So please pay attention. It's really, really simple. And if I get far enough down the page, I might go into the finding common denominators today because it'd be better to do that. All right. We have a shortened period because we're on the club day, but that's okay. Please listen carefully and concentrate. And I'm also trying to get as much work as I can done in class so you don't have as much homework. All right? But some of you, I'm trying to tell me, watching what I'm doing is not helping. You can't just watch. You've got to do the problems as I'm doing them. All right? That helps. It makes a difference. And some of you I know are frustrated because you're telling me you're studying. I'm telling you, if you do the review sheet 3 times, you're going to make an A on the test. If you can do the review sheet and do every single one correctly, you can make an A on the test. All right? And I know some of you are not doing that. All right? Especially those of you guys who say you want an A. All right? If you want an A, you're not doing your work to get the A. All right? That's not my fault. All right? Now, and if you want to prove that, what you can do is you can go and, I've recommended just duplicate the review and do it over. And then don't lie to yourself. The ones you get correct and the ones you get incorrect, star the ones you miss and then do it again. All right, until you finally get it. All right, math is mostly patterns. Math is mostly patterns. And once you establish the pattern, the problems become easier. All right. So with that, let's go ahead and let me talk to you about adding and subtracting rational expressions. All right. And again, this is a big part of the stuff that's on the SAT. All right. So I want you to snap together with me and let's go. I'm standing here for a reason. All right. So with that, if you were listening to me, the first ones start off with a common denominator. Now, why do you think everyone else in the class has their paper already up? Now you're already behind. All right. Do I have a common denominator already? Yes. So if you have a common denominator, all you have to do is add the numerators. If you want to borrow my iPad, it's over there somewhere. Okay. All right. So this becomes what? Beautiful. And then after you do that, you always reduce. All right. So in this case, the answer is just what? I'm telling you, it's really simple. 6 over x squared. It's really simple today. All right. Now again, do we have a common denominator?
Yes.
So the answer is just
7 over 3a plus 7.
Look how simple. All right. And that's the same way every fraction is. If you have a common denominator, then all you have to do is add the numerators. All right. So here's where kids make a mistake. What?
Would you not divide like cross into 7? It's bounded by addition.
Bounded by addition and subtraction. Thank you very much. Bounded by addition and subtraction. That's a good question. I'm glad you asked it. All right. Everything must be multiplication in order to cancel out. All right. So just to review up here. All right. We can cross this out because the 2 and the x squared are bound together by multiplication. All right. Drew, are you with me? All right, some of you guys, I was proud of your grades were much better. All right, which means hopefully you're working harder. Hopefully you can attribute it to that. All right, so here we go. The next one now, put a star by the next one because this one's the hard one. All right, so.
Wouldn't it be 2x minus 6 over x minus 3?
Exactly. So hold up. 2x minus 6 over x minus 3. All right. Now, here is where when you see a bunch of addition and subtraction, you have to check to see if you can factor and reduce, like we did last week. All right. So there is a common what?
X minus 3.
Whoa. We factor out a 2. All right. So you factor out a 2 first. There you go. So you have 2 parentheses x minus 3. All right. So every single time you simplify, and there's addition and subtraction involved, you then have to try to see if you can factor and reduce. All right, so in this particular case, now what? The x minus 3's cancel, then you're just left with 2. All right, 2 over 1, 2, whatever. All right, so now, again, for number 7, all right, we have the same denominator. However, you should recognize the denominator, we can factor out a what? 2. All right, so it becomes y plus 4. And now the numerator is just y squared plus 3y minus 4. Everybody agree? And now there's probably a what on the top?
Y plus 4.
There's probably a y plus 4 on the top. So let's see. All right, y plus 4. Now I need a y squared, right? So I need a y. And now I need it to be negative 4, so it has to be a minus 1. All right? So now we can reduce. All right, and if you knew last week's work, then you know this week's work. So my final answer is just y minus 1 over 2. All right, yes.
Wait, can you just go back to 5 real quick?
Yep, I sure can. Tell me.
Oh, all right. Oh, never mind.
You go with that?
Yeah, I'm good. So I get when you factor the 1, so it's 2y plus 4. But what about the other one? Like how is it just?
Because the y plus 4 is canceled out.
But they're
How did I get 2 times y plus 4?
No, I know how you get that, but there's like two of them, and only one cancels, so why is there only like two on the bottom? When you add the numerator, it's the y squared plus 2. But what do you do with the 2 on the bottom? Because the
He's saying
denominator
so you
is
can
the
get
same.
4y. Like adding.
Okay, so both of the denominators can be 2y plus 4, but only one of them can cancel. So what happens to the other one?
Oh, he's saying why isn't it like 2y plus 4 instead of 2y plus 4? Because there are two denominators. Because you already like added them. No, that's what he's saying. Because you don't add the. He doesn't understand why there aren't two like on the bottom.
The denominators are the same, right?
Yeah.
So it stays 2y plus 8.
But then what do you do with the
What do I do with what?
Like, I don't get how there can only be a 2 in the denominator. If there are 2 fractions, and only one of them cancels.
Okay, so if I said to you, James, 1/2 plus 1/2, what is that?
1/4 or 2.
One.
Stop talking.
Yeah, it's 1.
Do you understand now what I'm telling you? Because you have the same denominator, you're not adding anything with the denominator. The denominator is the same. So when I taught you 1/2 plus 1/2 is 2/2, most kids want to make it 2/4, right? But you're not. The denominator remains the same. All right, so here we go on number 9. All right, what do I have here?
You have
No.
6m.
Now hold up. I wanna make a little note right here too, because again, this is what's on most standardized tests because they know kids aren't very good with subtraction. All right. So with this right here, I would like you to change the subtraction to what? An addition. And then you have to do what? Distribute the negative. Exactly. So when he said change the signs, the 2m becomes a what? Negative 2m, and the positive 3 becomes a minus 3. Now, right now, normally what I tell kids to do is I circle it when you're first starting out. I circle it so I know that I have done what? I've changed the signs. That just helps me to know that I'm not going to make a careless mistake there. All right. So with subtraction, if there's multiple terms in the numerator, you distribute the negative. All right. And again, that's where most people make their mistake. They don't make the 3 negative 3. They can see the negative 2m, but not the negative 3. All right. So now we have 2m minus 10 over m minus 5. And now, of course, that's exactly like the one before that. All right. So we have 2 parentheses m minus 5. All right. And now what happens to the m minus 5? All right. And so you're just left with what? You're just left with 2.
Why did you only distribute the negative to the 2?
Where did you want me to distribute it to? Well, it's kind of like this. If I said 2 times 3x minus 4 plus 3 times x minus 5. I distribute the 3 here. I don't distribute it on the left. Or I don't distribute it on the left. Yes.
If you didn't change into addition, it would be the exact same answer.
Yeah, but you have to remember the problem with that is what I was trying to tell you is most kids look at that as negative 2m plus 3. Do you hear what I'm saying? So most kids say it's negative 4 instead of negative 10. You see what I'm saying? Right. So be careful. I'm trying to tell you this negative gets distributed through there. Okay? And you understood what I said now about you're not distributing to the denominator. So again, that was kind of important to look at too, because here I want you to see this. if I say negative 1/2, is that the same as negative 1/2? And is that the same as 1/-2? So everybody agree all those are the same, right? You don't put a negative on the top and the bottom. We're not distributing a negative on the top and a negative on the bottom. All right? You distribute the negative one spot. All right? All right. Here we go. Let's take a look now at number 11. Yes, it's really simple. Really, really simple. All right? So we're going to go with 3x minus 9. Hold on a minute. And then x squared minus x minus 6. Hold on. I appreciate some of your enthusiasm, honestly. But I'm trying to, I'm trying to let people grasp the situation. All right? And when you're saying things before I say them, it just makes it harder. All right? It just makes it harder. All right? So now, in this case, I have 3x minus 9 over x squared minus x minus 6. All right? Now, all you're doing is looking to factor. That's it, just like last week. All right? So we factor out a 3, and it becomes x minus 3. And then on the bottom, now what's probably on the bottom? Yes, there's probably an x minus 3 on the bottom. And then there's going to be an x plus 2.
But then it would just be negative 6.
All right.
Where do you get this 3x?
I'm trying to help you. Okay, I don't even see anything on your iPhone.
Oh,
Stop.
minus 3 plus 2. My bad. Sorry.
Yeah, whatever. You don't even have it on your open.
Like, oh, it. I didn't do that.
All right, now I have x minus 3 and x minus 3 cancel. So I'm left with 3 over x plus 2. 3 over x plus 2. Now, again, hopefully you feel like that's pretty easy. All right, nothing to it. All right, again, it's very beneficial for understanding fractions, for adding and subtracting fractions. Not really a big deal. All right, now, I notice now that we have to start a little bit harder now because we don't have the same denominator. All right, so we're just going to do a couple more problems for today, and then I'll turn you loose and let you finish up. But again, I want everybody to take a look at 13. All right, now you see that we do not have a common denominator. All right, so we have to make a common denominator. All right, now to find the common denominator, I always try to tell kids this. All right, I always try to tell them that start with the numbers. Start with the numbers. All right, and so 3 and 2 are not the same, so you're looking for the least common multiple. All right, which we already, if I said what's 1/3 plus 1/2, I'm sure most of you could tell me there's a denominator would have to be a 6. All right, so that's not the problem. All right, so this is 6 and 6. All right, now the question now becomes, it's called a common denominator for a reason. All right, what is common with x and x? There's an x. All right, so because the x's are the same, you don't have to change the x's at all. So the common denominator would just be 6x and 6x. All right, so everybody's got to listen really carefully with that. All right, now what I tell kids is you're looking at this fraction right here, and you're looking at this fraction. Those are going together. Now I changed the 3x to a 6x. So the question is, what did you multiply by? 2. You multiply by 2. And I'm just going to put this all up here. All right, it's not necessary because I think you're smart enough to see that. So that numerator then becomes what? It just becomes 10. That's exactly right. So it's 10 over 6x. Now you're looking at the second fraction, all right, and this is exactly how you do your common denominators. You're looking at that fraction, and you're looking at this fraction, and you're saying, what do I multiply by? 3, all right? Now, again, it's not necessary, but I'm just doing it for you. I'm multiplying by 3, multiplying by 3, so I end up, bless you, with 9 over 6x. Anybody have any questions? And now once you've done that, you're now exactly where you were in the first odd problems that we did. All right? So now all you're doing is adding the numerators because you have a common denominator. And when you add those, that becomes what? 19 over 6x. 19 over 6x. All right? So again, not very difficult. All right? Not very difficult. All right? Now let's take a look at 15. All right, so 15 again. All right, we don't have any numbers. All right, which makes it kind of easy. All right, so again, I always try to tell kids, in my opinion, I think you should just write out the two fractions. All right. Now, there is a common what? A. There's a common A. All right, so if you want, you can put A and A down. All right, now obviously I don't have to do that, but I'm just trying to show you that when we say a common denominator, you have to put what's common down. All right, so if I put what's common down, that eliminates that A and one of those A's. All right, does everybody see that? All right, now in order to get a common denominator, right, you have to take the largest exponent. And so this happened to be left behind, and we can't do that. All right, so you make the common denominator what? A squared. All right, so really, if I was telling you to do that, an easier way or something that you might understand a little bit better rather than doing the common is just to say, look, for the individual variables, you always capture the largest exponent and make that the denominator. All right, so we have an A and an A squared, so obviously the largest exponent is 2, so the common denominator is just going to be what? A squared. All right, now again, that leads us back to this fraction here and this fraction here. All right, so what do I need to multiply the first fraction by? A. And so what's 6 times A? 6A. So 6 times A is 6A. So I multiply this by A and this by A. Is everybody with me on that? All right, now on the second fraction, I just multiplied by what? 1. So it doesn't change. The denominator is already the same, so it's just what? 3. All right, is everybody good with that? All right. And now we're going to just go ahead and add them. All right, so we add them, 6A plus 3 over what? A squared. 6A plus 3 over A squared. Yes, sir.
Why don't you add that? How you multiply 6 by A? Why don't you multiply 3 by A?
Okay, because look, again, here's the important part about adding fractions. So I really want to help you, all right? So please listen carefully. This right here has a what in the denominator? A squared, right? So you're looking at this denominator, but I'm going to change color just so I can see this A squared, and I'm looking at that A squared. So it already has an A squared.
Oh. So that
Right.
means you don't have to multiply by A?
Right. You're just multiplying actually by 1 because it doesn't change. Right? It's already, it's like this. And I always try to tell kids, try to relate it to something. If I say 1/3 plus 1/6, the common denominator is what?
3.
The common denominator is 6, right?
Oh, yeah, sorry.
That's all right. You see what I'm saying, right?
Yeah.
The common denominator is 6.
Oh,
So I multiply this by 2.
But you don't, yeah.
You see what I'm saying?
Yeah,
So I don't have to multiply both fractions all the time. All right? If it already has the common denominator, you just don't have to multiply by anything. You good with that? All right. Now, is it necessary to factor out the 3? Not really. All right, but sometimes it can cancel. So right now, if you want, you can say 3 parentheses 2a plus 1 over what? A squared. So does that really make a difference? It didn't make a difference. All right, so you really wouldn't have to factor that. All right. All right, let's look at 17 now. All right, for 17, tell me what the common denominator is.
Okay, so is it mn?
Yes, very, very good. All right. Now notice what I'm going to do here, guys. You see the minus sign? I would really like you, because I think it's in your best interest, to change it to a plus and make that a -2. All right, now it really doesn't make it that much of a difference for this problem because there's only a single term in the numerator. But in the future, it could make a difference, and that's where kids make their mistake. All right, so we're really going to say plus here. And then we're going to say the common denominator is what? Mn. And the common denominator here is Mn. Everybody good with that? All right, by the way, what time's the bell ring? We have 5 minutes, right? Okay, perfect, perfect. All right, so now what am I multiplying by?
So for the first denominator,
Shh, let her talk.
you multiply by n.
Very nice. Multiply by n. So the numerator becomes
2n.
2n. On the second one, I'm multiplying by.
M.
Very nice.
It's -2n.
Very nice. -2m. Now in the future, what I'm doing on the left is not necessary if you're good. Does everybody understand that? Right? If you know what you're doing what I'm doing about multiplying isn't really necessary. All right? So now the final answer is
2n minus 2m over n.
very, very easy. Very easy. All right? So last one for today. I promise. Last one. 19. All right? So now this is about as hard as it's going to get, right? So what I want you to do is, again, set it up. 2 fractions plus. I just think that's a easier, better way to do it. All right, so now you look at the individual denominators, the numbers. A 4 and a 3 would have to be a common denominator of what? 12. Is everybody good on that? Common denominator has to be 12. And then you have a b squared and a b cubed, so I would need a what?
b6.
B what?
B6.
B cubed. Now b6 would work, but you would end up reducing. All right, you would end up reducing. So some of you guys who weren't listening to me, now you've got your attention because you now have to understand what I'm saying. I have a b squared and a b cubed. So you always just take the largest one. I didn't say you add them. I didn't say you multiply them. I said you look at b squared and b cubed and you tell me which one's larger, b cubed. So that would be the denominator. So the common denominator would be 12b cubed. 12b cubed. And now I multiply the first fraction. Give me the number that I'm multiplying by. 3. And then a what? B. I'm multiplying by 3b. Because I have how many b's? And I need how many? I need 3 total. So you're correct. I just have to multiply by 1b. All right? So now look, again, that's super important now. So I multiply the top and bottom by 3b and 3b. Is everybody happy with that? All right. And then when I get that, I end up with what? 9b. Now the second fraction, I want it to be 12b cubed. Right now it's 3b cubed, so I only have to multiply by what? 4. So again, hopefully you realize how important this is. If you know how to add, subtract fractions, it's easy. If you had trouble adding and subtracting fractions, this is just a very good review. All right? So now this ends up being what? -20. Negative what? Because look right here, very important. In this denominator is a what? B cubed. I need it to be a what? B cubed. So I'm not multiplying by anything, right? In this problem right here, it was b squared, and I need it to be what? so I had to multiply by b. Agreed or not?
Yeah.
All right. So now my final answer is just what, guys?
9b minus 20 over 12.
Good job. And now you can't reduce any of that. All right, so that is your answer. Good job. Yes.
Oh, okay, I see.
All right. So again, tonight, guys, listen to me. The 2 through 20 is your assignment, and then I'll do that with my other algebra class, and so you can double check your work. Please get in the habit of double checking your work and make sure it's right. All right, and then tomorrow we'll finish up the worksheets. All right. Hopefully you're going, wow, this is kind of easy, because it is.